In this video, we're going to talk about the normal distribution with z-scores. So you typically know you have z-scores because they give you a chunk of the z-table to actually do the calculations. And if you were to draw your normal curve, the numbers that we are getting in here probably wouldn't match. So scores on a test are normally distributed with a mean of 81.2 and a standard deviation of 3.6. Use the table below to find each probability. So we've got a z-table, we're going to be using z-scores. So it helps to make sure you know your z-score formula. So z equals x minus mu over the sigma. So remember, this is your mean, and this is your standard deviation. All right, so the first thing we're going to do is we're going to try number 4. We're going to calculate the z-score. So this is the z-score for number 4. So I would do, this is the x, so 74 minus, and then up from the instructions, we know the mean is 81.2 and the standard deviation is 3.6. When I actually put this in my calculator, I end up with -2. Now let's talk about what that means for a second. So what that means, actually, before we do that, let's find out in the table. So in the table, I'm noticing -2 here. So my probability or my area under the curve is 0.02. So let's think about what that means. If we're on the curve, okay, we know the mean is 81 point whatever, 2. 74 is going to be down here somewhere. What it means is this down here, this value here from here out, is the probability is 0.02. The problem we have with this with this calculation is it will only ever get us values that are below. In order to get values that are above, we're going to have to do something else. So that's what we're going to do in the next one. So a randomly selected student's score is above, red light should be flashing, something else is going to have to happen, 88.4. Okay, so first let's just calculate the z-score. So this is for number 5. So 88.4 minus 81.2 over 3.6. When I do that calculation, I get a +2, meaning my probability is this. However, what that actually means. So there's my normal curve. I know my mean is 81.2. I know the value we were getting is 88.4. But what this 0.98 means is that it's all these values here is the 0.98. But we were supposed to be getting values above. We were supposed to be calculating over here is what we wanted. That's what we need. We know that this entire curve is equal to 1. So what we do is we take the probability and we do 1 minus this probability that we calculated, and we get 0.02. 0.02. All right, the last one that we're going to look at here is the number 6. So now we have to decide if we're between two scores. So what you do is you calculate the z-score for both. So I'm just going to do some funny notation, 81.2. So that's just notation, meaning I'm calculating the z-score for 81.2. So that's my x value minus my mean all over 3.6, which is going to be 0, meaning the probability I get for this when I look at my z-score table is 0.5. I'm going to calculate the z-score for the 84.8. Again, that's just notation. So I put in my x value of 84.8. Subtract my mean, divide by my standard deviation. And when I put that in my calculator, I end up with a 1. So I go to my z-score table. My 1 was a 0.84. So now what I'm going to do to figure out what's between those is I'm actually going to just subtract the probability. So 0.84 minus 0.05, and I end up with 0.34. So 0.34.